The top on the maps test is this one. Under exponents, just jot this down. The exponents. Why can't I get a brush? Brush. There we go. And the little subheading on this, ladies and gentlemen, is fractional. Which tends to throw people for an incredible loop, which is this. Take a look at this example and tell me what you think of this. What would be 64 to the 1/2 power? Is not that?
Would it be 64 times 32?
Sure, no.
That's fine.
You're just going to take half of 64 and say, I'm going to take 64 and multiply by 32. So you, generally speaking, just the random thought processes of math just don't necessarily work.
Well, there's no random math. It's just a ton of random thoughts.
No, they're not random. Math is as ordered as you can be.
Yeah, well, it's got to be created somehow. So the person who created it just
Like I told you, the principles of mathematics, first of all, one of God's characteristics is He is a God of order, which is another reason why creation is the thing. Here, a thought on the whole process of things. Wade Davis, you have a bedroom, correct? If you do nothing to your bedroom, I mean, if you just live in your bedroom and do not work on keeping it clean, does it automatically stay clean on its own? Everything has a tendency to kind of scatter. When you leave things alone, they don't get more organized, they get less organized. Now, if you look at our creation, and the organization of it is, if you go and believe the people that say the whole Big Bang thing or thinking like that,
you should read
how could a world go from a big explosion into organization? When things explode, when a building explodes, do you end up finding little worlds being created? Do you end up finding things? No, it doesn't happen. It is completely against the laws of what happens out there. But our creation is, so they call that whole finely tuned thing. I don't even know where that was going. Oh, I was going back to math. You know, the math that you're studying now goes back to like thousands of years before Jesus. These people knew this way, way back when. Because the math is not anything new. Anyways, here's the deal with this. Take a look, see here. In order to simplify this, it works like this. I honestly can't tell you why. I'm going to have to think about it for a while. This 64 to the 1/2 power is the same thing as the square root of 64. Usually don't put that 2 there, but it did there just to show you that whatever this bottom number of the fraction is, whatever that bottom number of the fraction is, goes here. Whatever the top number of the fraction is actually becomes the exponent of the 64. But since it's a 1, it doesn't change 64. So the actual answer to this is 8. Now let's look at something a little more delusional here. I don't know if I can get one to work out. So if you saw this, well, let's do this one first. 8 to the 1/3 power is the same thing as, put 8 under the radical sign. The 3 goes out here, the 1 goes there.
2.
What is the third root of 8? 2. I was trying to think of one that would do, one that works out if you use like 2/3. 4, what if I did 64 to the 2/3? No, we got to keep it small. 4, oh, let's try this one. 4 to the 2/3 power. Yeah, probably should work, right? No. I don't think it would work. If you actually simplified this, it would be put the 4 under the radical sign. The 3 is that index number, and the 2 goes with the 4. So it actually ends up being the same thing as the cube root of 16, which I don't think we have. There's no cube root of 16. What if I did 8 to the 2/3 power? What would that work out to be? It'd be the cube root of 8 squared, which is the cube root of 64. Is there a cube root of 64?
Probably.
No, there's not.
Because 6 and there's 27.
The cube root of 27. What about the 2/3 power of 9? 9 to the 2/3 would be the cube root of 9 squared, or the cube root of 81. Is there one? No. 3 times 3 times 3 is 27.
I know it's possible.
Yeah, it's possible because
Because
plus
it's
1 equals
90.
9, so 3, 6, 9, so it should work.
The cube root of 81? What same number times itself 3 times gives you 81?
Oh,
4 times 4
I
is
think it's
16. 5 times 5 is 125, so that's not going to end up there. Anyways, they won't give you that. They'll give you most of the time they'll give you this half to the half power. Just know that anything to the half power is the square root of it. Anything to the third power is the third root of it. That's actually all they give you. And then, with that being said, take out a blank piece of paper because we talked a little bit about roots. I know we've mentioned this before. You know, you can have the square root of 64, which is 8. But what is the square root of negative 64? Tyler spelled this off before, but you can't do that technically. Why is that? Because square root means same number times itself. To give you negative 64, what number? Well, you put an 8 here, because you know 8 times 8 gives you 64, but there's no way to come up with a negative.
Well, if you put I.
Right. Okay, there's no way, though, to get a negative there. Because you either got to make them both negative or both positive. In either case, you end up with a positive number. So that is why, anytime you have, and this is what you need to write down, an even root of a negative number is what we call an imaginary number. There really isn't such a thing. We can't do this. Now don't get that confused. On the flip side, you can have an odd root of a negative number. Because you can get a negative with an odd number. You know what I'm saying? Picking up what I'm laying down here, for example, the square root, or I'm sorry, the cube root of negative 8. That is possible. Why? Because you can take 3 negatives times themselves, and that will give you a negative. So this is negative 2 times negative 2 times negative 2, which is simply a negative 2 is your answer. Odd numbers you can do, even roots you can't. So there's no way you can do this. If they gave you this, the fourth root of negative 100, you would say, I can't do that. Later on in math you'll be able to do it because they do. They call the imaginary number, this little letter I, they call that the square root of negative 1. Which means if you had this negative 8, if you had this, look at this, if you had this square root of negative 64, and you take a negative square root of 1 out, which is I, if I take a negative square root of that out, that means you're left with a positive square root of 64, which is 8. 8 times the square root of negative 1. But instead of calling this the negative square root of 1, they use the little letter I to stand for it. So this is what they would tell you the answer is. 8I, a little. You don't have to know that because it's immaterial to you, and it's not that you'll need to know it for another couple of years. What else can we do? Perfect. let's just forge ahead one more time. Another blank piece of paper. And we shall do what's called percent of change. Percent of change, only because this is kind of exciting. And a lot of times we think about this in stores with marks up and marks down. Mark up, mark down. Mark up, mark down. By the way, markdowns we always call having a sale, something's on sale. Which technically, when you think about the word on sale, when you go into a store, everything technically is on sale. On sale just means you can buy it, right? But we've gone to know that when something's on sale, we think you're getting some sort of a deal with it, yes? Sure, why not? Just go with me on that. All right, here's a Mr. Example problem. A music store marks up the price of a CD. Do you know what a CD is?
Yes.
Just check it. A music store marks up CDs that cost them $9, but they mark it up by 70%. What is the final price? Now this one, I'm thinking some of you could probably do this in your head, but really, for ones that you can't do in your head, you really want to understand the process of what the easiest way to do that. Does anybody know what the easiest way to do this? What do you think? Yes, a percent box. Did you say percent box?
Yes, I did say percent.
I did say percent box. Now you have to be careful with this percent box because we're not splitting things into pieces to get 100%. You are actually starting with 100%, which is the $9, and you are adding 70% to it. So your percent box for mark up and mark down looks like this. Here's your percent. Here's the real number. Okay. This is what it originally is, and that's always 100%. In this case, if it's a markup, you have to add the percent. Mark up. It's marked up 70%. So the final price percentage is 170%. And the original price was $9. You just need to figure out what this is. So if you're doing the math, what's it look like? You don't really need this middle box. 100 over 170 equals 9 over what number? Is there a quick way to do this?
Cross multiply.
Well, I'd reduce this one first so I don't have such a big thing. I'd cut those ending zeros off. So I would go 100 times n equals 9 times 17. 9 times 17 what? 153?
Yeah.
100
$13.30.
Oh, this was 10, wasn't it? No wonder. You said that doesn't add up. Yeah, move the decimal back one place. It is $15.30. But I need to find a hard one. Flip your book to page 296. Let's see if we can do a practical application of this. Look at example letter A. Read it to yourself as I read it aloud. A. Actually, the directions say find the percent of change. And when they ask for percent of change, that would be this. They want either the mark up, how much something went up, or they want how much it went down. So if you look at this thing here, January 2006, the person's salary was $600 a week. In 2007, it was $630. Is that going up or down?
Up.
Up. So your little box is going to look like this. Same one we just used. You've got Mr. Original. It's going up, and you get the final percent, the real thing. Now, it went from what to what? 600, right, was the original, to 630, that's the final. So how much did it go up?
30.
30. What do I know about the percents?
The original's 100.
We only know this one. That's all we need to know. As long as we got one, we can fill in the rest. And then, like I said, it's asking you for this. Anytime they ask for percent increase or decrease, it's that middle box. And that is your simple little 100 over what number it is, 600 over 30. I still would also reduce if I could.
50.
Yeah, I could still reduce, couldn't I? 3 goes into 60 20 times. 20 times, what is 100? Where 50 came from. And actually equals 5. Say 5% increase. You don't really get marked up on your salary for 5% increase. How about letter B? Number of words in the first draft was 1,032. The final draft was 774. Is that an increase or a decrease? We haven't done an increase or a decrease, so let's do that one. This time, your increase slash decrease looks like this. It's decrease, so it's going to be minus whatever this is. This is still, original is still 100%. Finals here. This is percent. This is actual. It went from 1,032 to 774. Which means you have to do some subtracting here. What is 774? 12, 8, 5. 258, is that right?
Sounds right.
And am I looking for final percent or the decrease? Looking for the decrease, so I just need those pieces there. Ooh, I wish I had a calculator. But I'm going to do it just because you shouldn't give up on a problem, just because it's hard. Wade, did you get somewhere on here?
I got to be here now.
Congratulations. How about this? Let's let's cut them both in half and see what happens. What is this? 516 over 129.
Seems about right.
Can I do anything else? Can I divide them by 3?
Yeah,
Well,
no.
Sure I can.
Yeah.
Because this is 12 and this is 12. What is that? 3 goes in this 1, 7, 2. 3 goes into that 43 times. Uh-oh. Now we're in trouble. Unless you know that 43 goes in 172 how many times?
4.
Wow, look at you. 1, 4. Now it's pretty simple. 4 times what is 100? 25. 1 times 25 is 25. So my percent decrease is 25%. Nobody else is excited as I am about this?
Oh yeah, we did math.
So for that problem, since it's a decrease, would the answer be negative 25% or just 20%?
No, you would just say it's a 25% decrease. Decrease. Alright. Let us, just because it's Thursday, and just because it's a long weekend. Let's just do everything. No, I want you to do practice C through F, and anything else that has a 47 on it. There's not very many, I don't think. I see 2 problems,
1, 2, 3,
just 2
4.
problems. So a total of 6 problems would be all you have. That's unheard of these days.
Especially